Okay, ladies and gentlemen, let's take a look at starting geometry. Now, one of the biggest things that we need to do when we start taking a look at geometry is we need to understand that geometry is not really a separate subject from the other math subjects. It's just a math that's in a slightly different form. And in fact, where we need to start is we need to start with algebra. So let's go ahead and take a look at an example. 4x plus 2 equals 3x plus 7. In this case, very simple algebra problem. You have one variable. You have variables on both sides. But what we're wanting to do here is we're wanting to solve for x. So everybody take a moment, solve for x. Okay, now, hopefully when you solve for x, you did among the following. You did minus 3x from both sides and said 1x plus 2 equals 7. Then at this point, you did your next step. Well, obviously, your next step is going to be what? It's going to be minus 2 from both sides because we want to get all variables to one side, all numbers to the other. And so by doing so, we come up with 1x equals 5. Now, that's not bad algebra, but it's a little bit lazy and it's a bit sloppy. We have good write out. We have all sorts of steps shown, but what we haven't done is we haven't labeled what we've done for each step. So now what we want to do is we want to go back and we want to label each step. This first step right here. Well, that's what the problem is. That's what we were given. So in fact, that's what we're going to call it. We're going to call it the given. Now, the next step is not this step. This is just my work. The next step I actually have is from here to here. So the question becomes, how did I go from here to here? The step that I took was subtraction. I subtracted 3x from both sides. But we need to give it a bit more of an official name. This is the subtraction property of equality. Because the only reason I'm able to subtract subtract 3x from both sides is because indeed I have an equal sign in the middle. So it's the subtraction property of equality. Okay, fine. How do we get to the next step? Well, this is not the next step. There's no equal sign here. There's no other operators. All that is my work. The next step is right here. How do I get from here to here? Again, what did I end up doing? I subtracted 2 from both sides. So that is going to be the subtraction property of equality. You'll notice I'm doing a little bit of abbreviating because that's a whole lot of words. But subtraction property of equality. And there we have it. X equals 5. And I'm done. Now, let's go ahead and do another problem. Next problem. Let's go 5 parentheses x plus 3 equals, let's put a 2 over here, 6 and x minus 3. Okay, give that a whirl. Now, once you've given that a whirl, hopefully you have a number of steps. The first step I would think would most reasonably be to get 2 out of the denominator. Now, one of two things could happen. You could theoretically put this over 1, and now you have a fraction equals a fraction. What is a fraction equal a fraction? What is it called? When one fraction is set equal to another fraction, what is it called? It is a proportion. It is a proportion. And how do I solve proportions where I have one fraction here and I have one fraction here? What would you do? That's right, we're going to cross multiply. Now, I could cross multiply, in which case I would get 12x minus 6 equals, and this times 1 would be 5 parentheses x plus 3. That would do it. Alternatively, instead of saying cross multiplying and using proportions, I could just say, since this whole side is divided by 2, I could multiply by 2. Multiplying both sides by 2 would accomplish the same thing, wouldn't it? We would indeed have 12x minus 6 equals 5 times x plus 3. So either way you choose to do it is equivalent. Now, at this point, what's the next step you would probably do? Hopefully you said distribution, and we're going to give away that 5 to each piece. 12x minus 6 equals 5x plus 15. Okay, once we have this, now what we can do is we can say by distribution, I distributed this, I can now begin combining things. So subtract 5x from both sides. And so I come up with 7x minus 6 equals 15. I'm now going to add 6 to both sides. When I do so, I come up with 7x equals 21. All right, that's going to work out a lot better than I thought it would. And when I get 7x equals 21, I'm now going to divide both sides by 7. And by dividing both sides by 7, I get x equals 3. It works out very, very nicely, and we've solved it yet again. But remember, it is not any good unless you can tell me how and why. So let's see how we did. First of all, this piece up here was given. Now, in this case, you could give me two different reasons for how we moved from this step to this step. For some of you, you may say cross multiply. But others of you say, no, 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 no. I multiplied both sides by 2, and so it would be multiplication property of equality. Okay, multiplication property of equality. Either one of those is 100% correct because, again, there's variety in how we solve these. In fact, if you might even do this problem in a slightly different order than me, but that's okay. It doesn't really matter. Now, to move from here down to here, what did we do? I said it repeatedly. We distributed. We use the distribution property. Now to move from here to here, we subtracted 5x, so that's going to be subtraction property of equality. And finally, to add 6 to both sides, that would be addition property of equality. Addition property of equality, APE. And finally, to get from here down to here, we divided both sides by 7, so that's going to be division. And with division, we are done. What we're really doing, ladies and gentlemen, is algebraic proof. Now, that's a very simple version of algebraic proof, but it's algebraic proof nonetheless. Let's take a look at one more tougher example. I want to take a look at the following. 4x squared plus 2x parentheses 3x minus 7 equals 4x plus 1 quantity squared. Okay, I want you to do a couple things for me, see what you can do to solve that. First things first is I would probably suggest that we distribute this term to each piece. So I get 6x squared minus 14x equals parentheses 4x plus 1 squared. Now, I was really tempted to FOIL this out and multiply that out. I'm not going to do that yet. I want to do each step as an individual piece. So I'm not going to mess with that yet. I'm now going to combine these two, and that's going to be by some crazy secretive term called addition. That's right, people, addition. All right, now, in that case, we are now ready to do this multiplication. Now, we could have done this multiplication at a previous time, but we simply didn't. So let's go ahead and do that now. I have 10x squared minus 14x equals 16x squared plus 8x plus 1. By the way, if you're not quite sure what I did there, I went ahead and FOILed that out. Write it twice, multiply it all through. All right, at this point, now we're ready to begin solving. Minus 10x squared minus 10x squared negative 14x equals 6x squared. Don't forget your squared, almost forgot my squared. Plus 8x plus 1, add 14x to both sides. I come up with 0 equals 6x squared plus 22x plus 1. You'll notice I'm getting 0 by itself each time because in order to solve for x, we actually have to put 0 on each side. And unlike these problems right here, I actually have quadratic. Quadratic meaning a squared for my x. With that, I'm going to need to use a different trick. I could attempt to break it up. 3x, 2x, plus, something. But that's not going to work. I'm probably going to have to go to the quadratic formula. Opposite of b Negative 22 plus or minus the square root of b squared. 22 squared minus 4 times a times c, all over 2 times a. If I go ahead and put that together, I come up with negative 22 plus or minus the square root of 460 all over 12. And you say, great, I can just put that in my calculator. I could have just solved it up here. No, you can't. You got to do it by hand. And you can't even leave the square root like that. You're going to have to simplify square roots like big boys and girls. So what we're going to do now is we're going to break it up. We're going to say, hey, square root of 460, that's 2 and 230. That's going to be 2 and 115. That's going to be 5 and 23. There's my prime factorization. Now with the prime factorization and ending on 23, not a lot I can do with that, but I can bring that 2 out. So now I can divide top and bottom by 2 and come up with negative 11 plus or minus the square root of 115 all over 6. And that is what x equals. Now, if we're going to go back and put our reasons in, here's our reasons. Right here, I distributed. Here, okay, I'm sorry. Excuse me, I've already messed up. The very first thing is given. Then how did I move from here to here? Now I distributed. Okay, and how did I move from here to here? I added. Now, I don't say addition property of equality because I didn't add to both sides. I only added to one side of the equation, so it's just straight up addition. Now, at this point, how did I get from here to here? I multiplied out. So that's going to be by multiplication. If you put FOIL, I would be happy to have you put FOIL there too. That's a very nice method to use. In this case, how did I get from here to, it doesn't go there, it goes right here. How did I get from here to here? The answer is I subtracted negative 10 from both sides. So that's going to be subtraction property of equality, subtraction property of equality. How did I get from this step right here to this step right here? That we added 14x to both sides, so that is addition property of equality. And how do I get from here to here? In this case, I use the quadratic formula. Quadratic formula is my reason. How did I move from here to here? I simplified. And that creates a proof for algebra. What I'm going to do is I'm going to go ahead and throw in another couple examples. And once we've done that, then you can do those examples for homework along with the questions that are included.